here we are transforming a cubic function. Let's take a look at it. F of x minus 3 cubed plus 2. Again, this exponent 3 makes all the difference. So what are the transformations going on over here? Well, pretty straightforward. In the first case, this guy here, we have a horizontal shift. This is right 3 units. And in the second case, this guy over here, we have a vertical. I'll shorten it up, shift, and this is up 2 units. So what does that look like? Well, let's refamiliarize ourselves with the original cubic function. It looks something like this. Goes through here, and it goes through here. And that kind of point of inflection is at 0, 0. What's going to happen to this? Well, the whole graph, and I'm going to make a copy of it so we can see it, is going to move 3 units to the right. So 1, 2, 3, and then 2 units up. So 1, 2. So our new graph is going to be roughly over here. Again, if you have grid paper, that looks more accurate, and go down here. So there is no stretch, no compression. In this graph, it's just a pure shift right and then up. And what is this? 3, and over here we have 2. So it's like the middle of the graph has been moved that way. There is another way to do this. If you want to use kind of a table of values, if you recall, x and y, if I put -2, -1, 0, 1, 2, I cube everything, so I'm going to get -8, -1, 0, 1, and then 8 over here. I mean, what I could do is actually, find out where all these new points are using this mapping notation for, transforming these functions. So what is the mapping notation? Well, in this case, I'm going to put, with the x value, I'm going to add 3 to whatever x is, and for the y value, okay, it's +2, okay? Because essentially what you're doing is you're, moving every x value over 3 units, and you're moving every y value up 2 units. So if I were to take in, for example, let me apply this mapping transformation, this point here, right? I have the number -2, -8. What does that become? Well, it becomes 1, -6. Okay. I can then look at the point -1, -1. What does that become? That becomes, in this case, 2, 1. And then I can go from 0, 0, and that goes to 3, 2, and then from 1, 1, that takes me to 4, 3, and finally 2, 8 takes me to 5, 10. And if you plot all these points, okay, all these resulting points, this guy here, if you plot this guy, you're going to get basically, the points lying on this graph, and you can just fill in the rest because you know that it makes sense for all values of x. So as far as the domain and range go, well, domain in this case is equal to the range, which is equal to, let's write the set itself, all real numbers. Okay, this is the set of real numbers going from -infinity, wherever that is, all the way to +infinity, wherever that is.